Design patterns presented by Group 5. Let's see the road ahead. Now, as the first part, we introduce three design patterns: the abstract factory design pattern, the prototype design pattern, the builder design pattern, and we compare each of the three design patterns. Now, let's talk about the abstract factory design pattern. Now, it's a creational pattern and provide an interface for creating families of related or dependent objects without specifying their concrete classes. Now, let's see the idea behind the abstract factory design pattern. Now, the factory object has the responsibility for providing creation services for the entire platform family. Clients never create platform objects directly, as they ask the factory to do that for them. Now finally, abstract factory patterns work around a super factory which creates other factories. Now let's see an example. Now the example is a car factory. Now the car factory has several other small factories producing wheels, hood and doors for different models. Now the super factory just creates the model car for a given model of a car. Now the prototype design pattern, it's a creational design pattern and specify the kinds of objects to create using a prototypical instance and create new objects by copying this prototype. Now let's see the idea behind the prototype design pattern. Now it declares an abstract base class that specifies the virtual clone method and maintains a dictionary of all clonable concrete derived classes. Any class that needs polymorphic constructor capability derives itself from the abstract base class and registers its prototypical instance and implements the clone operation. The client then, instead of writing code that invokes new operation on the same class, calls the clone operation. Now the example is so we have several shapes and we want to get the shape. We don't create new instances, thus create clones and return the shapes. Now let's further clarify it using a familiar instance. Now we have to have a account transaction system. Then we would want to make a copy of the object that holds your account information, now performing transaction on it, and then replace the original object with the modified one. In such cases we use clone instead of new. Now the builder design pattern is a creational design pattern, and the builder pattern builds a complex object using simple object using a step-by-step approach. Now the idea of the builder design pattern is, now it decides if a common input and many possible representations are available. Now then creates the complex object using simple objects step by step. Now let's see the example. Now we have a complex burger made of simple objects and a cock. Now this is a restaurant example which creates a complex meal object using simple objects and wrappers. Now let's compare each design patterns. Now let's decide on the focus. Now the focus of abstract factory emphasizes a family of products, either simple or complex. Now in prototype design pattern provides one instance of a class for use as a breeder for all the future instances, while the builder focuses on constructing a complex object step by step. Now let's see the return values of these different design patterns. In abstract factory, the product may be simple or complex, get returned immediately. Now in prototype, the clone objects are always returned. Now in the builder, it returns a product, a complex object, as the final step. Now let's see each of the methods used in these patterns. Now in the factory method, creation is through inheritance. Now in prototype design pattern, creation is through delegation, while in builder, the inheritance is the method used. Now let's see the usage of each design patterns. Now an abstract design pattern is used to organize code. If you end up with many factory methods, and in your code you see a common theme between some of them, you can gather this group with the abstract factory. Now, prototypes are useful when object initialization is expensive and you need a copy of an already filled object. That's the clone of the object. The inherent intent of the builder design pattern is to separate the construction of complex object from its representation. Now let's consider other facts. Now, factory method requires subclassing, while the prototype doesn't require any subclassing, and builder design pattern also requires subclassing. The other factors are: the abstract factory has the factory object producing objects of several classes. The prototype has the factory object, it's a prototype, building a product by copying a prototype object. Now, the builder has the factory object building a complex product incrementally using some protocol. Abstract factory classes are often implemented with factory methods, creating through inheritance, but they can be implemented using prototypes as well. So, prototype is unique among other creational design patterns because they doesn't require any classes, they only require objects. Now, abstract factory classes are often implemented with factory methods, but they can be also implemented using prototypes. Now that concludes our video presentation, and thanks for watching.